Hi, welcome to this lesson on statistics, mixed exercises part 2. Let's have a look at question 3. The table below shows the mass in kilograms of the school bags of 80 learners. Okay, so you can see the intervals here. The mass being strictly greater than 5 kgs, less than or equal to 7 kgs. There are 6 students in that school out of the 80 that have a school bag that weighs that. Another example you could read off this table, 11 students have bags that weigh between strictly greater than 13 kgs, but less than or equals to 15 kgs. Okay, so the first question reads as follows. Write down the modal class of the data. So again, wherever the highest frequency occurs, that is at 21. So therefore, the modal class is going to be between 9 and 11 there. So 9 less than m less than or equals to 11. So the most amount of students' bags usually weigh between 9 and 11 kgs. Okay, the next question says complete the cumulative frequency column in the table above. Okay, so remember for the cumulative frequency, you start off with that number there, 6. Then you add 18, that'll give you 24. Add 21, that will give you 45. Add 19, so if it was 20, it'd be 65. Minus 1 is 64. Plus 11, that's going to be 75. Plus 4 is 79. Plus 1 is 80. Okay, so that is the cumulative frequency column. So doing that, I already predict the next question, and that's going to be to draw the ogive curve. All right, so what I've done is I've set up this table to use the endpoints as my curve. So I've done this deliberately like that. Sometimes what they'll do when they give you their own table, they might start at 0 to 5, 5 to 10, and so on. As long as you're placing those correct values for the intervals within that established table, then it is fine. I've just gone ahead and drawn the table so that my endpoints match up nicely to the values I'm going to be putting my dots in. Okay, so for starting at 5 is our ground point. So that's where we'll start here. And it goes to 7, and that frequency cumulative is 6. So there's about 6 over there. Then again, the endpoint 9, your cumulative is 24. So when I have 9, 24 is going to be somewhere over there. Then I'm going to have when m is 11, it's going to be 45. So 11, 45 is exactly halfway between there. Then at 13, I'm going to have 64. So 13, 64 is somewhere over here. Then I'm going to have 15 and 75. So 15, 75 is over there. Then I'm going to have 17 being with 79. So that's going to be just before 80. And then the 19th one ends at 80. So over there. Okay, so if I connect that, make sure you're always connecting from your ground point, where your interval starts, in this case 5. And we draw our ogive curve. Okay. Next, we want to use that ogive curve, that graph, to determine the median mass for this data. So there were 80 students. The median means exactly halfway, so 40 students. And then I'm going to try and do this as accurately as possible. And I see I'm coming down all the way to here. So between 9 and 11, there's 10. And this looks like it's almost partway between 10 and 11. So I would say that the median mass Q2 is approximately 10.5 kgs. Because remember, your x-axis is talking about the mass of the school bag, and your y-axis is the cumulative frequency. The international guideline for the mass of a school bag is that it should not exceed 10% of a learner's body mass. And this is due to many factors. If a student's carrying a bag that is heavier than that, it can put strain on their body, and that causes stress and exhaustion, which you don't want in school. Okay, so the first question is to calculate the estimated mean mass of the school bags. So now how do we do mean in group data again? So again, we use that specific formula. So x bar is going to equal to, again, similar to normal means, you're going to divide by your total, in this case, the cumulative frequency of 80. But now this time, you are going to take the frequency value, right, the frequency f, and then multiply it by the midpoint of your interval. So that is the established formula for the mean of group data. So what is in between 5 and 7? The midpoints, which I'll call m here, that's 6. Between 7 and 9 is 8. 9 and 11 is 10. That's going to be 12, 14, 16, and 18. So your x bar is going to be looking something like this. So you're dividing by 80. So you take your middle point and your frequency and you multiply them. So 6 times 6. plus, then you take your midpoint 8 and your frequency, and you multiply them. Then next you're going to have 10 times 21, plus 12 times 19, plus 14 times 11, plus 16 times 4, plus 18 times 1. So just make sure you do this calculation very carefully in your calculator. So on the top here, it's going to be 6 times 6, which I can do in my head is 36, 8 times 18, plus 10 times 21, that's going to be 210. If you're not comfortable, maybe do these calculations separately above here, work out their values independently, and then add them all up to be safer. Otherwise, if you're feeling confident with your calculator, you can put it all in at once. 16 times 4, and then 18 times 1. So that's just 18. And that's all divided by 80. Okay, so you get the mean X bar is going to be 10.675. So 10.68 kgs to 2 decimal places. So that is the estimated mean mass. X is 10.68 kgs. Now the mean mass of the group of learners, so not the school bags, the learners now, was found to be 80 kilograms. So on average, a student at that school is around 80 kilograms in mass. On average, are these school bags satisfying the international guideline with regard to mass? Remember, if they are satisfying, it means that the school's bags, the weights, mustn't weigh more than 10% of the learner's body mass. But the average learner's body mass is 80 kgs, okay? And 10% of 80 kgs, that's going to give you, well, 10% of 80 is 8 kgs. But notice that 8 kgs is less than this estimated mean of the mass of the school bags that we found at the school, which was 10.68 kgs. So what can we conclude from this? Well, since the mass of the school bags on average outweigh 10% of the average student's body mass, we can say that this school is not satisfying the international guideline for the mass of a school bag. All right, so something will need to be done here in order for students to reach that value, because maybe they are carrying too much textbooks, the textbooks might be weighing too much, the equipment might be weighing too much, and so on. So the school needs to take that into account. All right. So that's how we would do this type of question. I'll see you in the next one.